Simultaneous equations. The word simultaneous means at the same time. So we have two equations here which can't be solved if we only have one of them, but if we know that they're both true at the same time, i.e. the x in this is the same value as that and the y in this one is the same value of that, then we can actually solve them. So this is how we do it. Okay, the first thing we need to do is look and either find, or we'll find in future examples, adjust these equations legally so that we have either the x parts the same or the y part. So you can see in this example the y's are already the same value. So in this case what we're going to do, we're going to literally take away these equations. So you can think of it like a takeaway sum if you like. So on this side we've got 6x take away 4x, which gives us 2x. And here we've got y take away y, so that is gone, and that's why we're doing the takeaway, because it gets rid of the y. And here we've got 15 take away 11, which gives us 4. So 2x equals 4, so that means that x must equal 2. So now we know what the x value is for both of these equations. We now need to work out what the y value is. And we do that by picking one of the equations and substituting the x value in. So I'm going to use the bottom one here. So we've got 4x, so 4 times 2 is 8, plus y that we don't know yet equals 11. All right, so taking away 8 from both sides, we can see that y equals 3 in this case. So we need both the x value and the y value for these simultaneous equations. I'm going to do a few more examples, also to demonstrate some slightly more complex ones. So if we look at these ones here, what we don't have that we had in the previous example is either the x's or the y's don't have exactly the same numbers. Don't worry about the signs, it's the numbers that have to be the same. So what we're going to do is we're going to transform this one so that it does have the same number of y's as this one does. So we're going to multiply the whole thing by 2 so that we've got 2y here. So I'm going to put that underneath here. So we're going to have 8x minus 2y equals 6. So we've literally just doubled everything. And remember, as long as you do the same to both sides of the equation, that's perfectly legal. Now, we've got 2y here, but that's plus, and we've got negative 2y here. So if we took away in this instance, we wouldn't get rid of the y's. So for this one, we're actually going to add instead. So we've got 3x plus 8x, so that gives us 11x. 2y plus minus 2y gives us nothing, that's why we're doing it. And 16 plus 6 gives us 22. So hopefully you can easily see that that means x must equal 2. So now we've got to substitute back in to work out what y is. So I'm going to use this top equation here. It's always best not to use one that you've changed, but one of the originals. So 4 times 2 is 8, minus y that we don't know at the moment, and that equals 3. I think without going into it too much, I think you can all see that that means that y has to equal 5. Okay, couple more examples coming up. So here we've got the same sort of situation again. Neither the x's nor the y's are the same. Okay. Now the difference here though is that I can't turn the x's into each other or the y's into each other. So I'm actually going to have to change both equations this time so that we get the same number in front of one or other. In this case, we're going to get the same number in front of the x's and the y's, so we can choose which one we want to do. Okay, so let's go for eliminating the x's this time because we've done the y's. So I'm going to make both of these into 6. So that's the smallest number that 3 and 2 goes into. So I need to multiply this equation by 2 and this equation by 3 to make that happen. Okay, so we're going to have 6x plus 4y equals 26. And for the other one, we're going to have 6x plus 9y equals 21. So I've just multiplied all of this by 3. So because these are both positive, we're going to do the takeaway version. So 6x minus 6x is nothing, they're gone. 4y minus 9y is going to give us minus 5y. And on this side, we're going to have 26 take away 21, which is going to give us 5. So that means if we divide both sides by minus 5, that y equals minus 1. So now we're going to take that and substitute it in one of the equations that we have up here. So I'm going to use the top one. So we've got 3x plus 2 lots of minus 1, so that's minus 2, equals 13. So we've got a slightly more complex one to solve this time. So we're going to add 2 to both sides to get rid of the minus 2. So that will give us 3x equals 15. And then divide both sides by 3 to find out that x equals 5. So another example here. So again, neither the x's nor the y's. Sorry, I've written those the wrong way round, haven't I? Let me just change that. So that's 5x there and 2y there. Sorry about that. So obviously having a funny 5 minutes there. But can't turn 5 into 7 or 2 into 3. So I have a choice here. So which one am I going for? If I want to eliminate the x's, the smallest number these both go into is 35. I'd rather not go there. Whereas here, the smallest number is 6, so that's a better option. So to make this 6, we need to multiply by 2. To make this 6, we need to multiply by 3. So we just literally multiply everything. So we're going to have... All right, I'm actually going to do this a different way around. So I'm going to do this one to go on top. You'll see why in a minute. So we've got 15x minus 6y equals 33. And then multiplying this one by 2, but writing it underneath, we're going to have 14x minus 6y equals 10. So we're trying to eliminate the y's because they both have the same sign. That means we are going to do a takeaway. So we do takeaway when they have the same signs. We do adding when they have different signs. So 15x take away 14x, and this is why I wrote them the other way around to make that a bit nicer. Minus 6y minus minus 6y, which basically means minus 6y plus 6y. That's why they eliminate each other, is nothing. And then on this side, 33 take away 10 is 23. Sorry about that. Right, so now we need to take that and substitute that in. I'm going to do it into this one here. So we've got 5x, so that's 5 times 23, minus 2y equals 11. Sorry, run out of space there. So 5 23s. 10 23s are 230. Half of that is 115. So we've got 115 minus 2y equals 11. Now this might seem a bit bizarre, but this is usually the way people get this better. I'm actually going to now add 2y to both sides. So that'll leave me with 115 here equals 2y plus 11. So now I'm going to take away 11 from both sides. So that will give me 104 on this side equals 2y. And then if we divide by 2, we get y equals 52. So that's simultaneous equations.